Ukraine obliterates Crimea's air defenses as $620 million radar network collapses instantly. Before the sun even rose, Ukraine executed one of its most precise deep strike operations of the war. An attack that didn't just hit Russian defenses, but systematically erased them in minutes. Drones flying lower than a small fishing boat shattered radar systems, outmaneuvered missiles worth millions, and crippled the very sensors Russia depends on to guard Crimea. A K-27 helicopter exploded before it could even lift off. The S-400 network went blind, and entire radar stations vanished from the map. The strike shifted the Black Sea operational balance, and to understand how it unfolded, the sequence returns to where it all began. Today, a coordinated Ukrainian drone strike began offshore in Western Mir, an operation designed to dismantle Russia's most protected early warning network and inflict more than $620 million in aviation, radar, and air defense losses within a single hour. What followed was not a chaotic swarm, but a staged suppression campaign aimed at blinding Crimea's western flank and opening the peninsula to future strikes with far less effort and far lower cost. At 2:29 a.m., 7 Ukrainian and 196 Lyuchi sea-skimming drones moved in from the Black Sea, flying just 13 feet above the surface at a steady 102 miles per hour. Each platform carried a forward-mounted HI penetrator incendiary warhead and used radar-absorbent composite materials that reduced its radar cross-section to about 0.05 square meters, effectively smaller than a seagull. Their course pointed directly towards the ATRI Ridge, where Russia's primary early warning radars watched over the entire Black Sea basin. Above them, at 2,500 feet, a PD-2 reconnaissance UAV with the call sign Ghost 4 activated its infrared payload and began constructing a digital map of the ATRI mountain slopes. Within seconds, the quiet ridgeline became a layered battle space. Radar antennas, launchers, hangars, patrol routes, and sensor cabins emerged as distinct thermal signatures. The mission shifted from simple ingress to a structured kill chain, with targets arranged and prioritized in real time. Ghost 4 identified a critical threat on the map, a warmed-up K-27 anti-submarine helicopter at Kacha Air Base's eastern apron. This helicopter was the sole local aviation asset that could use ground radar to detect low-flying sea drones, potentially exposing the entire Ukrainian formation. To ensure the strike's success, the K-27 had to be eliminated pre-takeoff. Ghost 4 tagged all key systems and processed the data locally, then uplinked the full target matrix through a secure military Starlink channel. Within 2 minutes, the AN-196 formation received synchronized assignments. Drone 1 would strike the K-27, Drone 2 the 96 L6E radar, Drone 3 the Nebo SV radar, Drone 4 the P-18, Drone 5 the LRA-A-10 navigation radar, Drone 6 the BK-16 patrol boat, and Drone 7 the Pantsir S-1 battery, or its backup command node. In one data burst, a single drone group turned into a distributed suppression package aimed at every layer of Western Crimea's air defense grid. Commands were transmitted via frequency-hopping spread spectrum, with channels shifting every 5 seconds. Each hop re-encrypted the signal, forcing Russian electronic warfare units to chase constantly moving frequencies. Attempts to jam control links or hijack guidance failed as quickly as they were initiated, leaving Russian operators with radar tracks they could see but not reliably target or disrupt. The drones then fanned out into 7 independent attack vectors, separating laterally while remaining low and hard to detect. The first Russian naval response near Sevastopol involved a Baikov-class patrol ship detecting faint, low-altitude radar contacts, initially dismissed as sea clutter. After repeated confirmation of the tracks, the ship launched 5 high-value surface-to-air missiles. Despite the barrage, all AN-196 drones remained on course, resulting in no confirmed kills. The next defense, a Pantsir S 1-point defense battery on the southern coastline, launched 557 E-6E missiles worth over $18 million at 2:35 a.m., but all detonated harmlessly in the empty sky. Switching to their last resort, the crew fired dual-2 A38 M30 mm autocannons, opening sustained 30 nm autocannon fire at a high cyclic rate, with rounds splashing into the sea. The Lucci drones evaded the radar by being programmed to slide perpendicular to the radar beam and hold a Doppler notch at 164 feet, appearing as background clutter. While Pantsir crews tried to understand why working radars, functioning missiles, and autocannons could not produce a single kill, Ghost 4's infrared feed captured a second Ukrainian drone group entering the battle space from another direction. Inside the Kacha Air Base Command Center, Russian operators began pushing emergency procedures, launched the K-27, shift radars to manual UAV hunt modes, widen coverage arcs, re-establish track continuity. In theory, the measures could have restored some situational awareness. In practice, they were already too late. The Ki-27 never left the ground. As the helicopter started to roll along the apron, Drone 1 came in on its attack vector and struck the fuselage with its HI penetrator warhead. The blast tore through the airframe, ignited the main fuel tank, and sheared off the rotor mast. A vertical fireball engulfed the helicopter, while shrapnel tore into the adjacent radar cabin, wrecking equipment racks and starting multiple fires. Within 20 seconds, the air navigation section of the apron was burning, and the only rotary wing platform capable of supporting maritime detection in that sector was destroyed. As flames spread, Drone 2 closed on the 96 L6E radar, the key target allocation system feeding S-400 batteries in the region. At 2:36 a.m., it climbed to 60 feet, locked its angle, and nudged its speed up to optimize penetrator effect. Impact shattered the antenna assembly, ripped cooling grids apart, and drove molten copper into the signal processing core. Displays flickered once, and then died. The 96 L6E went dark, and every connected S-400 launcher immediately fell into passive standby. Without target designations, Russia's flagship long-range air defense system became a line of inert cylinders. At Gwadskoye Air Base, a Russian Su-30SM scrambled to intercept a reported UAV wave using R-73 missiles and Bars-N radar. However, the contacts were Lucci decoys, programmed to emit conspicuous signatures and draw fire. Bars-N struggled with scattered, inconsistent tracks as the decoys evaded stable lock by shifting altitude or using Doppler nulls. Under pressure, the pilot launched an R-73, but its infrared seeker lost lock, the missile drifted, and self-destructed, marking another failed intercept. While Russian aviation chased ghosts, Drone 3 completed its attack run on the Nebo SV radar. At 2:47 a.m., it dived from 72 feet, striking the radar dome dead center. Composite panels peeled backward under the blast, while the penetrator jet burned through the transmitter core. Within a second, Nebo SV's signal vanished from the spectrum. With that single hit, Crimea lost its only platform capable of tracking stealth aircraft and high-altitude threats across the Black Sea approaches. Drone 4 hugged the mountainside on the way to the P-18 radar, flying just 20 to 26 feet above the terrain and using natural shadows for concealment. At 2 hours, 47 minutes, and 59 seconds AM, it slammed into the antenna base. The explosion snapped the rotation shaft and ignited the signal module. The last functioning low-altitude radar on Crimea's western flank buckled and began to burn, completing the collapse of the low-level surveillance layer that was supposed to detect drones like the ones attacking it. Moments later, Drone 5 crossed the auxiliary runway and lined up on the LRA-A-10 air navigation radar. At 2 hours 48 minutes and 15 seconds AM, it struck the rear service hatch at 30 feet. Inside the housing, the penetrator detonated among transmitter components. Doppler processors, phase generators, and switching circuits fused into slag. Kacha Air Base lost its navigation radar instantly, leaving any returning Russian aircraft without guidance in low visibility conditions, and further degrading aviation safety at one of Crimea's key airfields. Inside the S-400 Kuban command post, alarm indicators flared as all major air defense radars, 96 L6E, Nebo SV, P-18, and LRA-A-10, failed simultaneously. The entire system went blind, losing nearly 40% of Western Crimea's radar coverage. Low-altitude detection, long-range sea surveillance, and layered coordination collapsed. A supposedly fortified region became a blind spot, its radar network severed by small, low-signature drones. Russian command centers circulated internal reports, acknowledging a near-complete loss of situational awareness, but none were admitted publicly. At the same time, Ukraine's Military Intelligence Directorate released infrared footage of the strikes, including the K-27 erupting in a vertical fireball and multiple radar installations burning along the ridge. Open-source analysts matched the imagery to satellite views and geolocation data, confirming the exact positions at Kacha and ATRI, and leaving little room for denial over what had been hit. The loss of the Kar-27 went beyond the physical destruction of a single airframe. Although not a fighter, it was central to Russia's maritime patrol and anti-submarine framework in that sector. Its ability to coordinate with surface ships and shore-based radars made it vital for tracking Ukrainian naval activity and low-altitude drones over water. Losing a combat-ready K-27 at Kacha narrowed the Black Sea Fleet's patrol reach and complicated its navigation and patrol planning, with replacement aircraft and crews neither quick nor easy to field. The destruction of the radar network carried even broader implications. Crimea's layered air defense wall had been peeled open in a matter of minutes. From this point forward, Ukrainian deep strike operations against Western Crimea would require fewer drones, face less concentrated missile fire, and enjoy higher probabilities of success. Analysts assess losses at roughly $620 million in aviation, radar, and air defense assets, counting radars, aviation assets, missile stockpiles, and command infrastructure removed in one coordinated strike. By the time the final plume of smoke drifted over Kacha Air Base, Crimea no longer resembled the fortress Russia had portrayed. Ukraine had shown that even the most sophisticated radar architecture could be taken apart node by node, using relatively inexpensive drones, flying just above the waves and guided by precise, networked intelligence. The psychological effect of a low-cost UAV neutralizing the sensors guarding an entire peninsula extended beyond this single night, undermining confidence in rear area security among both commanders and support personnel. Ukraine emerged from the operation with something difficult to measure but strategically significant: greater initiative, enhanced confidence, and expanded operational space. Western Crimea's radar shield had collapsed, forcing Russia into a reactive posture across the Black Sea and compelling it to divert resources to patch vulnerabilities that had not existed hours earlier. Supply routes, airfields, ammunition depots, and naval logistics hubs all became more exposed to subsequent strikes. Today's strike delivered a clear message. Under its current configuration, Crimea is no longer secure. Ukraine has demonstrated that it can penetrate, dismantle, and exploit Russia's air defense network at a cost far lower than the losses it imposes. With more than $620 million in Russian aviation and radar assets erased in a single, coordinated operation, the question now facing analysts is straightforward and unresolved. What Ukrainian strike will follow this one? And when it comes, will Russia have any reliable means left to stop it? Share your thoughts below.